All right, so guys, welcome to electrostatic class, physics 102, physics 102, and in this video we'll be giving a brief introduction to electrostatic. Right, so let's start and from a basic introduction. So let's assume this is a piece of sliced bread, and the sliced bread is cut into different parts. Now let's assume that we are taking this part. Let's say this is this part and this is the part. We cut this part into different parts. We pick this part, we cut it into different parts. Now we keep on cutting this bread to a point whereby it is no longer uncuttable. Uncuttable. I don't know if that word is correct. So we get to a point at which it is uncuttable, and we call it what? An atoms. We call it an atom, right? And of course, you know from your basic knowledge of chemistry that atom is divided into three subatomic particles, which are the protons, the neutrons, and the electrons right? So our basic concept will not be focusing on neutrons, we'll be focusing on protons and electrons, because most especially electron, because this is how we come about the concept of electrostatic. Right now we have charge. Before electrostatic, we need to understand the difference between charge and electrons. Charge and electrons, most students usually confuse these two things, right? They are two different things, right? Charge is an integral multiple of an electron. So this is the difference between a charge and electrons. Right now, charge charge can be positively charged, it can also be negatively charged. But how did we come about the concept of electrostatic? Now let's assume this is the electron we have. Now if the electron is moving, it is not at a stagnant position. That is when we come about magnetism. That is when we bring in the concept of magnetism. But if this electron is at static position, or at a neutral state, it is no longer moving. So it simply means that this is when we come about the concept of electricity. This is how we come about the concept of what? Of electricity. If the charge is at a stagnant position, it is not moving. So all of these those lights that comes in our respective home, is as a result of the charge being at a constant position. So that is how we come about electric charge and electric magnetism. So electrostatic, the word electrostatic is basically for electricity, while the word electromagnetism or electrodynamic is for magnetism, right? So there are two different things. Now there are some important concepts you need to understand about charges. Let's say this is charge, positive charge, and this is negative charge. There is a distance between these two charges. There's a distance. This is the distance between the two charges. So we'll consider the distance. Likewise, we'll also consider the current. Since we are dealing with charge, there's no way you talk about charge without considering the concept of current. In fact, before that, there is a formula, Q is equals to CV, that relates the electric potential and the capacitance, right? So this is Q is equals to CV. Similarly, Q is equals to IT. Now we need to take note of this formula, but this is not what we are discussing. What we are discussing is the charge and the current, and the unit for charge is coulombs. The unit for charge is coulombs, and the unit for current, this is current, IT, this is Q equals to IT. The unit for current is ampere. So we need to give a basic introduction. Now this charge and this positive charge and negative charge, we can bring in the concept of magnetism. When we are bringing in the concept of magnetism, then we are introducing the north pole and the south pole. But in cases like this, if you bring two positive charge, if you bring a positive charge and a negative charge together, the addition of the two force of the two charges will bring about the force of attraction. The force of attraction. But when you bring positive charge and positive charge together, you have a repulsion. A repulsion. So quickly, let's move to the next page so we can discuss some other concept about electricity. So a charge is approximately a charge, one electron is approximately 1.60 times 10 raised to power minus 9 coulomb. So electrons and a charge have the same unit. So E is the unit for electron is coulomb. In this case, we are regarding it as a charge, which is still the same thing as Q. So that's the relationship. Meanwhile, don't forget that we said that Q is equals to NE. So a charge is an integral multiple of E, where N is an integer. So an integer, what's an integer? Integer can be positive, it can be negative integer, right? So you can see electrons to be negative, electrons to be what? To also be positive. So we can say that Q is equals to 2E. This is correct. We say Q is equals to 3E. This is correct. Q is equals to 4E. This is also correct. So the number of electrons, so this is what we mean by the number of electrons in a charge. That's what we mean by the number of electrons in a charge. So quickly, let's see the value. Okay, we've taken the value already, which is 1.6 times 10 raised to power minus 19 coulombs. So let's discuss some other concepts, which is Coulomb's law. Coulomb's law. Coulomb's law. So what is Coulomb's law? So Coulomb's law is more like an electrostatic force between two different charges. Now, we already said something about charge 1. This is positive charge 1. This is negative charge 2. So what Coulomb's law is trying to discuss is that there is an electrostatic force between this charge and this other charge. So there is a force between this positive charge and this negative charge. So that depends on the amount of charge on each object and the distance between the two objects. So definitely there is a distance here. So what Mr. Coulomb is trying to say is that the relationship between these two charges means there is a force between the two charges, and he gave us the force to be F equals to K Q1 Q2 all over what? R squared being the distance between the two charges, and the value for K to be 1 over 4 pi E naught. So this is also called the permittivity of free space, and this has a value of 9 times 10 raised to power 9 Newton meter squared per coulomb squared. Please take note of this unit. It is very, very important. So quickly, let's move to let's quickly move to E naught. All of the parameters that we have here. So this is called the permittivity of free space. So this is called the permittivity of free space.